session here, and you're up for a treat. We're gonna have the world first live demo of Skylab experiment as a service. And you're all gonna be our guinea pigs because we haven't had a dry run or anything, but I'm sure everything will go super smoothly. So it's going to be a sneak peek on a release of a service we want to release sometime this summer, but we figured we'll give you a sort of a sneak peek. All right, let me get up. With the cookies, I'm just going to fall asleep otherwise. So we've heard, this is just a quick intro, and then we'll go to the live. We've heard about a thing I usually don't like to hear much because it's used all over the place, the paradigm shift. But in our case, I think it applies really well. We've really embraced the consortium of jointness. We have actually, a really strong joint collaboration across all these partners here to really share as much as possible, but without actually imposing a single approach and having scientific diversity in all what we do through mutualized tools. Next, please. So there's a lot of work happening. You've seen quite a few examples during the workshop. You'll still see some more in the next day. So there's a lot of deployments of JEDI with different models on different applications, on different platforms, with different configurations, different algorithms, different choice of observation QCs, and so on and so on. So really, how can we actually make sure that we still have enough to actually build these efficient connections? So that graph on the right here is showing that success that we have in jointness right now. When you look at applications, and here are a few examples, we have FV3, so global, this is UFS and GEOS through that global model interface. SOCA for the marine, land is with the WRF Hydro National Water Model, and an MPAS. If you look how you assemble the code and what's running, actually, a lot of the code is generic, reused. So this is all the green and bluish code. The specific code is the red, which is really the model interface. Our goal is actually to keep the specific code as manageable as possible. There's always going to be specificities, so that's totally fine. But whenever you have actually overlap of needs, then a joint solution can have actually a lot of benefits. So next. So what we need in order to keep things really joint is that generic testbed of Skylab, that generic testbed of JEDI, and that's called Skylab. So you've heard Mariam talk a little bit about it, and so that's what we're actually going to show you today is how Skylab can be a really powerful tool for multiple uses. Next, please. So you can think of it as a concept car that's actually bring together different pieces, and you can actually test it and take it for a test drive and see how these pieces are performing, how we are actually meeting the needs. And that can be a really helpful tool to go to the production car, that operational deployment that various agencies want to do. And you can iterate multiple times and pick what you like, drop what you don't like, and go like this. So it's really about rapid prototyping and validating these developments through that point of convergence where you don't have to reinvent an entire end-to-end system every time you want to test something. The other thing is, we've talked about agile development, continuous integration. Part of it is making sure that we have a continuously functioning system that can be used that has basically these latest capabilities that are tested and that can be demonstrated. And once we have something that works, we want it to work in the long run. so that we don't end up in a situation where there was something that worked 6 months ago, but no one's exercised it, and then we don't even know if it works anymore. It might be broken, and you end up actually fixing your own bugs. The other thing, so all of this is really about system hardening, looking at performance, looking at robustness, and skills. So this is very oriented toward research to operations. But there's also the revert direction, the O2R, where basically all these nice features, state-of-the-art capabilities, you also want to actually lower the bar for the communities who have access to it, and not have them have to worry about what data formats the data came in, what kind of data ingest, and what kind of workflow, how do I build the system, where it's going to run, and so forth. So really providing a turnkey ecosystem for people to start running experiments in that real world configuration, not just a toy model, but actually in that real world configuration can be really helpful, because now we can actually engage a lot of community members into that development. Next, please. So Marianne showed that slide earlier on, and I'll just explain quickly the part that is very important in our requirements for that experiment as a service, which is basically that generic testbed. We want the different components to be generic reusable, and that is what the Joint Center is about, and that makes this unique to other applications. Is actually going to be multi-purpose, easily reconfigurable, where you can actually add new data regardless of where it came from, and you go through that YODA API. So basically, we have the JEDI data convention, naming convention. So basically, you don't need to know where the data came from. It's basically populated in YODA format onto our data store that we call R2D2, that has everything on shelves ready to go. Next. Then we want a workflow that can run experiments, fetch all the data necessary for this, can actually grab all the codes and the code for your given configuration. So that means, which components you want to run. Is it the marine, the atmosphere, the composition, and so forth. And what model interface we need. So you need a flexible build system, a flexible workflow that can actually be generic and work on your laptop, on the cloud, on an HPC, that can work with different compiler versions, and that you can really easily repurpose. We also want to go end-to-end and have actually a series of diagnostics that can help you doing science, and then figure out what are the next developments, so that you can go into the agile development and do the next coding. Next. So part of the requirements is actually, we want to make sure that from the get-go, we consider Skylab not just as a specific DA for one component, but really as a sort of integrative Earth system component, where you have the various components like atmosphere, the land, the marine, the aerosols, trace gases, all under that one umbrella. You have one data flow, you have one workflow, one suite of diagnostics, one way to build, and you can actually use it for each of these components separately, or all of them together as well. So it's not solving any of the issues of the scientific issues of coupling, but basically it's providing a really nice framework to look into all these type of things. The other idea is you want to have the ability to swap models easily, and we'll show you an example. So this is a quick recap of Skylab now is actually released on a quarterly basis. So every quarter we have a roll-up release with all our software, and it's actually publicly released, all the JEDI software. And we actually run experiments to show the software is actually running, and we can analyze the data. And the idea is, because everything is under development, you want to see what are the latest capabilities. And here's an example from V1, V2, V3, and V4, where you see the different instruments being assimilated in the assimilation for the atmosphere and marine, the composition, land, and so forth. And so you see these different instrument types. Initially, we started pretty small and then added more and more. And just for the V4, here is basically the snippets from the release notes that tells you about the platform being supported, the infrastructure changes, and so you can actually go to a website and see that. So it's a nice way to plan future developments and actually release these developments in a coordinated manner. Next. So we talked about having all these different components of the Earth system under one umbrella. And if you can go next, I'll just show examples of plots that are directly cut and paste from our website. And you'll see a lot more through these demonstrations here, where you can actually have quite a wide range of observations and diagnostics that cover all these different components right now. Next. And that's it for me. I'm just going to go back and sit and listen.
So as Tom was saying, we have all of those results that are publicly available. If you want to look at them, you can go on the website skylab.jcsda.org. And when you go there, you will be able to select which version of Skylab you would like to watch results for. So all of those actually are version 4. So I thought we would have version 1 and 2 also, but I guess not. If you look at, for example, the Skylab Atmosphere Land 4.0, so it's the one that just came out a month and some ago. When you select in the observation list, you have all the instruments we're assimilating, plus a few diagnostics, for example, the analysis, the increments, some ensemble mean, because we are running an ensemble as part of the Skylab Atmosphere Land experiment, and some standard deviation of that same ensemble. For example, if you wanted to look at AMSUA results, you would be able to look at different channels, you would be able to look at different diagnostics, and you would be able to look at the H of X or the OBS value. The number at the bottom here gives you how many observations were assimilated from that instrument for that window, and you are able to go through the different windows. This one ran for a total of 5 days, it looks like. And so you'll be able to go through that website, look at different instruments, different results, how well the analysis is bringing, your observation closer. All of those are available on the website, skylab.jcsda.org. Now, what if I want to run an experiment like that? I would go in our code. You would have to go down there a little bit, and download the JEDI bundle repository. JEDI bundle is a combined bundle that you can use to build SOCA. Now you will be able to build MPAS. You can build FV3. We hope to bring UFS. It's kind of the master bundle that can build any model you want. And you would need to have ECFlow installed on whatever machine you're on. It can be a laptop, it can be an HPC. Obviously, I'm not going to be able to run on my laptop an experiment such as Skylab V4 that runs with a very fine resolution and giant observation files. That would not work. But I would like to be able to run an experiment that is very close to that Skylab experiment. And so I'm going to show you how easy it is to take the parameter files that we used to run that Atmosphere Skylab experiment and modify it so I can run it locally on my laptop that's a 4-year-old laptop. So this is a YAML file. I'm assuming most of you have seen YAML files before. It's not very long, probably about 125 lines. And I'm going to be able to modify it pretty quickly to remove capabilities that we're not interested in testing right now, to lower the resolution, etc. I will not be running for a full month. I will be running maybe for, I don't know, 3 cycles or something like that. I will keep the 3D get cost function. I don't need to change that. I will probably forecast a little less long. So that would be at each analysis. I'm only going to forecast it for 6 hours. I'm going to keep the exact same list of all the observations. I might add one actually. But I will not be downloading the full observation files that we are assimilating right now. I would like a coarse sampling of it. So I'm going to be adding a parameter to just take only a coarse sampling of all those observation files. And I heard that we had a CRIS instrument we could add. So I'll just add another CRIS instrument. We had the N20, and I'm going to add the NPP also. I'll continue down the line. This here is to say that we are using variational bias correction, and we're cycling it. This whole system is cycling, will be cycling when I run it for just the 3 cycles. I have here my list of variables, which analysis variables and which background variables I am using with that system. And in the Skylab case, we were running an ensemble of data assimilation as well as a deterministic high-res control member control. Yeah, or control. I'm not going to be running the ensemble of data assimilation on my laptop right now because that would take too long. So I will delete the entire part that concerns the EDA, and I'm going to keep only the part that concerns the high resolution. So the EDA would stop here, and I'm just going to remove all of those lines. And that's it. And I will need to, since I'm only running a high res, I don't actually need to precise that it's going to be a high res. I can just take that whole part and remove the indents that we had. Now for my geometry, I'm not going to be running with the 25 kilometer resolution. I'm going to be running with way less than that. So I'm going to change that C384 to a C24 resolution. Same for the model. I'm keeping the same background error matrix, which was a hybrid matrix in this case, hybrid being static and ensemble. I'm going to run the inner loop at a C12 resolution. So I need to precise that my B matrix is going to be at a C12 resolution. I don't need 25 members. I'll just put 3. And I will also change the resolution here to be C12. I also have access to which algorithms I want to use for this. So I already said I'm using a 3D get cost function. I'm using an ensemble B and a static B, so hybrid together. I might want to do my minimization in the OBS space instead of in the model space. So I could change the algorithm here and just use RPCG, for example. I'm not going to do 100 iterations per loop. I'm just going to do 10. Or I'm going to target a gradient norm reduction to be 0.05, whichever comes first. And then I'm going to, of course, make sure that the minimization, the geometry used in the minimization is still C12. I'm going to output diagnostics of O- background and O- analysis. I'm going to create some plots that are the exact plots you saw on the website. Those plots are going to be generated as I run the experiment, and we'll be populating our experiments.jcsda.org website. And of course, since I'm only running on my laptop and I'm running with a very low resolution, I don't need all those cores and all those tasks. So I'm just going to run with a layout of, 0 nodes on my laptop, but 6 tasks. And I don't need 1 hour, probably just need 10 minutes. And that's it. That's all the changes to go from running that giant experiment
Sorry, Clementine. I know you are sharing through Zoom. Do you want to keep, can you keep an eye on the chat? There's a question in chat for you right now. Are you able to do that? Or when do you want to take questions? Right after you've run the experiment?
Maybe, yes. I just saw the question. I will answer it.
Yeah, thank you.
So now just save the file and quit so I can start the experiment, which just goes with one line. I'm going to create the experiment using the file I just modified, which was skylab.atmland.yaml. This typically takes 20 seconds to generate the experiment. And it's going to populate here the tree of tasks in our workflow manager. Right now we're using EasyFlow. And to answer the question, well, Eric answered, we have a search function to know which backgrounds, which observations are available in our database. So you can see here all the tasks that are being generated. And it's going to up on the right here in a minute. Now, the question was, how do you know which observations are available in the database? And Eric answered, Eric is the person who is writing and managing our database. And we have a search method to know which one is here. So the experiment has popped up here. You can see that at the first level, we have a get ini, which is getting initial conditions. How do we start the experiment? And then we have the AN loop, which is going to be the variational loop. In this variational loop, this is the one that's going to be cycling. So I stopped here just the day after Valentine's Day in 2022, and then going to go for about 3 cycles. You can see them here. It's because I reduced the number of cycles I wanted to go through. When boxes become yellow, it means it has run successfully. When they are green, it means they are running currently. Sometimes when you run this on an HPC, you will see it be in dark blue. It means it's submitted and it's waiting on nodes to be available. You can see here we got all of our observation files. So all of those turned to yellow. We managed to fetch all of them thanks to the R2D2 database we're using. We managed to get our background, and we managed for each member to also get the backgrounds. This is for the ensemble B matrix. I said we only wanted 3 members, so they are all 3 back. Yes, because I said I wanted some course. And on my laptop, I don't want to do the coursing after the fact. Very fast, yeah. And in that case, when we run on laptops, we're going to make sure that whatever actually makes it to your laptop is a low resolution. We do want to eventually make that an option on the fly. We'll see how we can. So the variational task is usually taking about 2 minutes because we have a lot of different observations to assimilate, even if those obs files are pretty low resolution. And then you can also see that I'm going to be creating some diagnostics. I have variational diagnostics that are log-based. It's going to be cost function. It's going to be, mainly cost function and impact of observation. I have analysis here that is going to be plotted and published. So any task that is named published will means it's going to get populated on the website. And of course, I have my forecast task that I need so I can go to my next cycle and have some background to start from. And in the feedback here, if you go down, you will see that it's saving all the feedback for the observations, and it's creating plots also and publishing those plots on the website. Now, for the sake of time, I'm not going to make you watch all those boxes turn yellow one after the other, and we can just go and start looking at the results. I have run this experiment already beforehand, and I can show you the results. And we'll also be able to see then as the plots get published and arrive, but they arrive one by one, and we're not going to refresh the page every 30 seconds. Yes. And so the way it works, I cannot see. I can't access the top level. So this is the experimental version of the website we just looked at earlier. This one gets populated with all the experiments that we have been running on HPC, on my laptop, or anywhere. So I need to select my name here. And then I can select an experiment. For example, I just ran something that I have previously ran before, atmosphere small. And I can look at some diagnostics that were log-based. So for example, this one, which is the fractional impact of each observation. Of course, I'm not assimilating a lot of observations right now, so those plots are not very scientifically relevant, but they are a good first step to know if my observer is working correctly. I don't have a crash in the system somewhere. I can also look at all the instruments I've assimilated. We could look at, for example, SOA. You can see here the coursing, which is way lower than what you have looked at before. Just added, I don't know, that Chris instrument. This one has 6 observations, but that's a very, very coarse sampling. We could look at GNSS-RO. We have a lot more observations. We are trying to keep a somewhat relevant ratio of how many observations we keep compared to how low of a resolution we're trying to run, so that we don't flood a low resolution background with a billion observations. You could look at aircraft. If we had aircraft, oh yeah, they are here. So you could see them over the US, and you can see that, we have the O-B that we were looking at before. Here, -999 is just because we're only running the control. But if we were running an EDA, we would have a choice here of, you could look at individual members. And I have run that for 3 cycles previously, so you can also go through the different cycles and look at the results. And the other experiment should probably be going steady now. I need to click my name. And this is the experiment I just started, and so you can see that the plots are starting to arrive, but we only have access to 1 cycle for now because it's not run all the way through just yet. This one, for example, JOJB would be a time series. If you are cycling your system throughout the entire month, you could look at, every cycle, what was your initial JO, what was your final JO. For example, I know that this one has run for a full month. And so if I look at the last cycle, or in the end, you're going to really see the impact of, when radio sounds are, and then when you don't have any at 6 p.m. and 6 a.m. So you get this movement throughout the day, and so we're trying to have as many, informative diagnostics as possible, with keeping in mind that we don't want to populate a billion plots every time we run something. We have some diagnostics that are log-based and some diagnostics that are actual feedback-based. But all the ones that are under the var diags key are log-based. And that's it for the... Okay. Does anybody have any questions?
I was just going to remind people to use a microphone so that everyone in the room can hear the question and people online.
Getting up too often. What's that?
Okay, so I'm going to continue the demo and then showing an example of our aerosol experiment that I talked about in my talk. Again, this is going to be a smaller experiment with lower resolution, and I'm going to show you what we need to change in the YAML in order to change the model and also some other setting in the experiment. So I'm not going to edit anything here. I'm just going to point out the main changes that we can see if we want to run a GFS aerosol experiment. So to start here, in the suite, we have cycling EDA for us. The model, we changed that from GFS to GFS aerosol. So that's the model that we are using. So here you can see that we are referring to all the tasks that are different between GFS and GFS aerosol. So there are like small tasks that are different, and we needed to code them a bit differently. So we have this here to use that. So we are running 3 cycles here, I think. And then as we go further, so the cost function is different for us. We are running 3D bar experiment in this case. And then the window mode is just 3D bar. So we are running non-cycling, meaning that I also mentioned that in our talk that we are not going to run model. We are not going to start the next cycle from the new feedback files. We're going to start it from background files. So that's different. Another difference in our case. And then, so Clementine talked about upsampling course, and then we have 4 observations, and you saw the results in my presentation from these instruments. So obviously the variables are going to be different for us. We have aerosol variables in our simulation, and we want to assimilate those. So we have that. These are different kind of keys or YAMLs that we need to use in our experiment. And also we will have 2 members and running with C12 and C12 resolution and 64 vertical levels. For the model, we are running identity model. So basically we are not doing anything. So the kind of feedback is going to be the same as our analysis. And then, so for background error, there are different options that we commented out this part. So this is just a simple identity static B that is very useful for testing if you are kind of trying to add a new task or a new feature and you don't want to spend like way too long on the variational step. You can just use this YAML. It's pretty simple and very useful. But for this case, we are using a static B for the variation step. Again, Clementine talked about these, so I'm not gonna point these out. And again, for plotting, we are plotting different variables, so this also changes. I think I covered everything. Okay. So I'm not gonna run this experiment because it's gonna. Oh, okay. So I'm gonna. Again, same as the experiment that Clementine ran. I'm gonna use create experiment.py, and then kind of use my YAML experiment YAML to run this experiment. That was quick. So if we go to our EC flow, you can see that the experiment is here. The experiment ID is this number, and we can use that when we go to the website to look at the results. Similar to the previous. Do you have a question?
So create itself just also launches it?
Yeah.
Okay. Okay.
Yeah, so it will create the experiment and start running it basically.
you guys are smart. I have a silly question. I don't really remember these things. I can remember yes or no, or can see the list, the schemes, the models. So how do I, do the configuration setup correctly? So I don't want to try one by one. So all these schemes, you have limits, right? You have a list. My question is, how do I set up? And, as a new users.
So when you're a new user and you're already familiar with maybe running at least C tests in the Jedi bundle, then you have a few extra steps where you need to make sure you can connect to our database. You need to make sure you have downloaded the appropriate repository, for example, the Skylab repository. And you will find already a list of schemes that exist that you can play with. And that is typically how we try. For example, when we added the Aero GFS model, we started from a GFS standard composition, and they didn't have a B matrix at the time, so we were using an identity. And you can build off something that is already existing and modify it and play around until you have all the blocks ready for your own model or your new observation or your new system.
Yeah, my question, if I was a graduate student, I was a graduate student, I pick up this, I said, open the YAML file. So how do I, is a list, is GFS, it's GEOS, it's all these things there, just open the YAML file. Can I see that, or can I go to some website to know? As a new graduate student, I have no idea about all these things. Okay,
we have a lot of example YAMLs that are very useful. Yeah, there's that, and also the documentation. You can refer to that. But I would recommend looking at the YAMLs that are already there, because there are a lot, and there are a lot of good examples there. But documentation is a good place too.
You guys have a few questions in the chat as well. If you can keep an eye on that, thanks.
Yeah, so I ran with 2 members because I'm running on a laptop that doesn't have the power to run more than, really 1 member already. So I'm not trying to fry it right now. So why 2 members? It's just limitations of my laptop. And can we change experiment ID if we would like? In my case, I forced it to be something readable when I was showing you the atmosphere small or aero small experiments. And Eric answered, yes, you can rename an experiment, because all of our experiments are stored in the database that I was talking about. And you can move from those 6 random characters to another 6 less random characters, or 4 characters, or what you want. Yeah, the other one was
Okay, so any other question while we are waiting?
I have 2 questions. Can we see how you specify the graph for the experiment? Because I think a lot of us will be interested in actually modifying the graph of how things are plumbed together. And a second question, we would like to run it with known prototypes for the model. What would it take for you to run UFS HR1, for example?
So we actually have 1 or 2 experiments running with UFS. So it's obviously a little bit more complicated than other models, but it's there a few examples. And Timothy has a talk tomorrow where she will talk about running with UFS. So if you can wait until tomorrow, you will see that. And for the graph, yeah, it's well, I can show it in a minute once my M is done if you want, but it's not a graph, it's a Python code. It's all Python based. I'll explain that.
Okay, so what about if you want to change to a GitHub feature branch of UFO and combine it with a feature branch from Ewok area and get both of those two things together in a Skylab experiment? How do you achieve that?
So you do have to start with the first step, that is building the bundle, so the Jedi bundle. And if in the CMake list of your Jedi bundle you specify that you wanted a different branch for UFO, then it will use that branch in UFO. And it's the same for all the Python-based code that is not being built. If you check out a feature that is different, it's going to use that feature.
Can you say also a little bit about R2D2? How the database is organized, input dataset, output dataset? I believe this is connected to R2D2 database, right? Will you say something about that or maybe later?
So I know that Eric was listening in, and he is really the R2D2.
Yes, I'm here to answer. Can you repeat the question, please?
Yes, you. I'm just saying, okay, will you tell us a bit about how R2D2 works? That's pretty helpful for students also.
Yeah, so we'll talk a little bit about R2D2 tomorrow, but basically R2D2 is a front-end Python API, which integrates with the MySQL server. The server indexes all of the metadata and data files, and then it also, in the Python the Python API then accesses the MySQL server, and it will go and find and fetch the data files that you request, depending on where your location is and where the data store is located.
And I think, Eric, you have a talk tomorrow, right? About R2D2.
Yes. We're going to be talking about R2D2, Yoda, and how those apply to FAIR principles.
Okay, so if there's no more question, it looks like okay. So it looks like we made some progress here. So you can see the two members, background tasks, analysis task. Member 1 is done. Member 0 is still running. Well, it's done. And now we can take a look at the results on the website. Okay. So here's the results. So the fractional impact. So we only see VIRS MPP because the other three are in monitoring mode in this case. So similar to what Clementine shows, we have different types of plots. We have analysis, we have increment, and we have the variables that we specified in the YAML got plotted here. So we have dust at different layers in right locations, which is good. And then sea salt. And then you can also pick different observations or instruments and look at O minus B, O minus A plots and compare the improvements. Yeah, and also we only ran for one cycle was done. So you can see that here. I think that's it for me. I want to stop this.
All right, so I'm going to continue here a little bit. First, I'm going to suspend that because of... Oh, okay. because I know Clementine wants a new laptop and she would love for me to fry this one, but I will try to keep it alive until the end of this demo. Obviously, we've shown you some GFS-based examples so far with VI also, and what Clementine has done with GFS. But I'm going to go back to what Clementine was doing, and which was the Skylab atmosphere and small, not small, no. Sorry, you're running the real thing. Okay, and you know, obviously, like everything we do at JCSDA, when we start, everybody tells us it's absolutely impossible to do, but this workflow can handle a whole bunch of models. So I'm going to show you a run with a different model here, and I'm going to run with MPass for this example. So I'm just going, one thing is going to change to a static B because I don't have the ensemble here on this laptop for MPass. So that's good. And then I'm going to just go and look for GFS and replace it with MPass. Not this one. I'm going to use the bias correction coming from GFS. I don't have one for MPass. So just changing GFS in MPass basically, and we have different YAML files that define you know what the variables are for MPass, and the resolution also is not specified the same way, so it's not a C24 or C12, but it's given in kilometers. So I'm just going to replace that here with a 480 kilometers, the one we have here. And I'm going to do inner and outer loop at the same resolution. So there we are. And then the other thing I'm going to change, so this MPI layout is not needed for MPass, and also I'm just going to use one task. Yeah. And oh yes. One other thing, so MPass is a little bit simpler, so the background variables actually here the same as model variables. So all this will be documented. Obviously, I've done it, but to answer the other questions that we had earlier, and we will put the idea is that we don't have the resources to do it immediately, but there will be a GUI on top of that. So instead of VI, you will have actually slightly more advanced GUI in the future that will give you menus of what you can choose, and you can also add your own YAML file if you want. Like as you see here is a path to a YAML file. If I wanted to change, let's say the background error matrix I'm using, and if you know how to use BUMP and how to generate a YAML file for BUMP, but a few of you know what to do now, you would just put in your YAML file there, and then the system will assemble, put it where it needs to go in the overall YAML file for variable DA and use that. And what else am I going to change? Yeah, I'm just going to change. So RPCG actually works with the class. I've tried it, but I'm just going to go back to the upper Rosati preconditions. Shows if I can spell it right. Yeah, and that's all. And so I'm just going to go back to the bit experiment here. So maybe I didn't make too many mistakes. Then it will work and run. Now, the nice thing, as you see, I didn't change anything related to the observations. I've kept the 3D FGAT cost function. I've kept, I've fiddled here with the minimizer a little bit, just, to go back to the more classic Derby-Rosati minimizer rather than the RPCG. But if we look at the results, once this has run, we'll have one run with GFS, one with MPass, and we can really compare apples to apples because it's the same YAML file for the observations with the same QC filters, the same observer, the same everything. So I think that's going to be a really nice tool to do some interesting some interesting science there where we can, we can start experimenting, compare. Hopefully we'll have geos in there soon. Yeah.
So what stands between, is it just SPAC? That's it? Once we, to get geos in there, it's just SPAC?
It's basically that, yes.
Okay.
Yeah.
Noted.
And yes. Okay, good. So yes, as soon as we have a version of geos that we can compile here, we'll add it to that system, and you'll also have geos as an option that you can run. So yeah, it's going to take between 1 and 2 minutes. I think the variation, goes a little bit faster with MPass, but still it takes about a minute, I think, to run on a laptop like this. Now, yeah.
No, I was just going to ask along the lines of what you were just saying of having the ability. Now you have all these experiments that are sort of similar, but not quite identical. Mm-hmm. Do you already have the framework to compare them, or you're building that framework?
We're working on it. It's not there yet, but we're working on it. Yeah, so just to show you, but it's not just GFS and MPass. Here I'm going to start one. I also have a Lorentz 95 model for the var cycling, but should run faster, and that Yeah, no, I'm trying to help her get a new laptop. That's yes. So oops, sorry, yeah. So here it is. It's going, with Lorentz model. Obviously, it's a lot faster. So things are here. You're going to start seeing you should start seeing the cycling very quickly. But the nice thing here, and I can show you the YAML file again for the Lorentz model, which I just started. And you will see it's very, very similar to what you've seen with GFS and MPass. It still has difference here of cost function for the var. But other than that, you have all the similar things. There's less observation, background error is simpler, but really it's the idea there is that when somebody is new to data simulation, they start with this tool, they run a Lorentz model, but at the same time, without even knowing it, they are already learning and building their knowledge so that later on they can run a full-blown operational system, all within the same framework, the same tools. And that's really the goal here of this entire system. Just like OOPS and JEDI itself is generic, the workflow here is generic as well. And it's built on the same design ideas as the data simulation itself. I start hearing the fan on the laptop going here. So since somebody wanted to see how the tasks are specified, yeah.
So this is about JEDI EDU. Seems that Skylab should be okay. You understand what I was going.
Yes. So definitely. So what I'm showing here with there's the Lorentz 95, there's the QG. So we are going to start building all this JEDI EDU on top of this tools, and really have something where students can interact, see the plots, and change something in their observation, run it again, see the plot. That's really the idea. So just to give you an idea of how the suite is generated, I'm just going to take I'm not going to show the entire file here, but the one I wanted is here. So for example, here I'm having it's a Python code basically that's generating this suite of tasks. So here, for example, I have a variational task with its configuration is taking a bunch of arguments here, and it's producing an analysis. That's the key. That's what you expect as an output from your assimilation. And then this AN, you see that here you have a forecast task, And the initial condition is, so there's still this line here, which is not very nice, but we hopefully we'll get rid of it at some point. And this forecast, so it's basically the initial condition is basically the analysis here. Sorry, but there's still a bit of syntax that needs to be cleaned up. But here we're passing the initial condition as an argument to the forecast task. And just from the fact that it says that the output of this one here is used as an input here, it's going to put the trigger here and know that I'm going to mess up your nice arrangement here. And so, and we see here that the forecast won't start until the variational is complete. And so it's only based on what's an output of a task is used as an input for another one. And that's why, for example, we have executable here is an input argument for this forecast. And if you look up at the top, there is a task called build Jedi. So until the build task is done, the executable won't be available. So the task that needs the executable won't start. So it's the entire system is built on that. Just a loop. Yeah, I can show you.
How would you specify that, these tasks can all run in parallel versus there is, that kind of thing?
It's just a loop. Like, for example, here, we have a list of observation and we have a loop. And because there's no, so it's the fetching of observations, but because there's no output of one that's used as an input to the other, it knows they can all go in parallel and there's no dependency. That's all.
So does it evoke that does all the parsing and say?
Yes.
So okay.
Yeah. So the only thing, if you want to make a change and add a task, you edit that one file and then create experiment, and the whole mechanics is hidden underneath. All right. Yes. And the laptop is not dead yet. Okay. Okay. Yeah, so you see the L95 has cycled already, several cycles. And the MPass is here. Here's your browser. Yeah. That's okay, so that's the experiment that we just started that's running with MPass, and it, as you can see, it's producing some fractional impact. I mean, given the resolution here, it's not always looking super good for some of the ops types. But at least you can see that it's running, and you can start debugging your stuff and testing, and then you can run some higher resolution. So I'm not going to go through all these plots because we have the same. So I'll just go back to and yeah, go ahead.
So so I think this is all very strongly dependent on R2D2, right? So
yes.
So the initial conditions, everything goes into R2D2?
Yes. Yeah, so all the observations files are in R2D2, and we have the command to fetch them when we need them. In the backgrounds as well. So here, because I'm cycling, it's actually only the first background that's needed from R2D2. And then when you run your cycling, it's actually using R2D2 locally to store an analysis and using it to start the forecast. But because it's cycling, it's all kind of self-contained, except for the first one when you start. Same thing for the bias correction coefficients. They're in R2D2. You fetch them, and then if you're cycling, then it's just kind of keep using it. You need the first one.
Yeah, Nick, can I make a quick comment here? So there was one misconception that came up in a previous conversation with other people, and just to clarify this for everyone, R2D2 uses a MySQL or MySQL server for storing metadata. The data is stored physically on disk as whatever netcdf or something files.
Yes.
The metadata only knows where to go and find the files. That was one of the concerns that the operational centers brought up is what happens if we hide all this data in MySQL thing. It's very difficult. So the data is physically on disk as a file, and the metadata metadata tells R2D2 where to go and get it.
Yeah, it's a good point. It's only the metadata that tells you where to find the file. And the file can be locally in your machine or it can be on the cloud. And R2D2 will know where to get it from. That's it. Where did you put the slides? Yeah. Go ahead. Okay, good.
I'm just going to look at the chat because we have lots of comments.
In case you have questions, yeah.
It seems like Eric has answered all of them.
No, good.
Thank you, Eric.
The laptop is dying.
Are you reading questions right now from the chat? Okay. No. So for an HP to run this on any HPC, and you really want to run a big experiment, it's just a matter of having EC flow.
Yes.
That's it.
Yeah. So if you, yeah, well, good.
It's a matter of having spec stack.
Well, we already covered that.
Yeah.
It's meant for the workflow, not for the model.
Yeah. EC flow is in spec stack.
Ah. I see.
Yeah. Can you put the slides? Because some of these things are covered in the slides. So, yeah.
So what if I wanted to use Skylab just to run a simple HOX on backgrounds that I already have somewhere and observations that we have somewhere else? Would I have to ask one of you to put that into R2D2?
Yeah, well, not really. You can do it yourself. So if you have a local R2D2, you can. So this, I'll let me go through this thing and I'll explain, and then Eric can explain even a bit more tomorrow. But yes.
One last question.
Yeah.
Let's say I didn't see how you were setting up your background area. Is it assuming that everything is the same for each models?
No.
Or, okay. So that's a task that's set up in the model interface itself.
Yeah, so it's basically it's a snippet of YAML that's the config you would use for bump or your identity background error covariance that you use, which in which case it's a fairly simple one. So it's the section of YAML that goes, in your when you run a JEDI assimilation, you have a portion of YAML that describes the background error. So you just put that in a file and you point to that file, and you can just go and replace that file by a new one if you have a new background error. Yeah, go ahead.
Yeah. So with ECFlow, I mean that pops up. That's like a browser-based GUI, right?
It's not a browser. It's an application. Yeah, it's not browser-based.
So I know we had chosen one of the reasons Silk was that we couldn't do that on Discover. What's our recourse?
Let's
run it a different way, like a TUI, instead of a GUI.
Yeah, no. So, well, it's on my next slide, but yeah. So basically, this thing is abstracting away the workflow, the actual workflow engine or whatever you want to call it. So ECFlow, and we have in the plan for this year to add the support for Silk. So you can choose if you want to run your experiment through ECFlow or through Silk, and
I didn't want to ask you that question directly because I thought we disincentivized you about doing Silk because we were doing it. Well, then why do we have to do it? But okay.
Yeah, I mean, we'll try to do it this year to have Silk support. I think, so we started with ECFlow because it had at the time when we started this work, it had the Python interface, but Silk didn't have. Silk now has it. Yeah. So it's easier to integrate with this system, which is fully Python based. So we will work on Silk support at some point. If some in-kinds want to help, they're more than welcome. Okay, so, well, we've gone for more than an hour, so I'll just go for some conclusion here. So, now, as you've seen, this eWork plus R2D2 environment, something we can run toy model, low res, full res systems. on laptops. It works in the cloud. We've run it on AWS, and we'll test it on different cloud platforms. And HPCs, we have a number of HPCs that we've tested this on. So mostly Orion S4, Cheyenne, a bunch of others, but we can add some more. It supports in principle everything that you can do in JEDI for changing your YAMLs is supported here, because it's just basically templated YAMLs that generate the YAML that you would So until now, most of you were looking at these very long YAMLs and editing them by hand to run JEDI. So now it's snippets. You have one YAML file for your B matrix, one for ops type, one for minimizer. So you just go edit these very small YAMLs, and the system will assemble them and generate this giant YAML that's driving the application. So it's a lot easier to work with that way. And we have created data sets in R2D2. So I think that goes back to the question from Guillaume. So R2D2 will contain some data that we curate that we will look after, and it will have some special labels that, okay, that's the kind of official supported set of data. But then, it's a database. You have a store command and a fetch command. Nothing prevents you from storing files in there. I mean, we've done it for testing. You have your files that you want to use. You have a store command. It will push all these files into R2D2, and then your experiment will run and will fetch them. And as long as you have the correct observation type and date and thing, it will just fetch these files. And so you just use the store command to put data in there. That's
have about 1 petabyte of data. Can I push it to R2D2?
If you have a storage, yeah.
But I guess the serious part of this question, do you see a federated approach where, say, NOAA provides a backend storage for, S3 for their data sets, and there is a way to connect your MySQL metadata to the data that we store in whatever way,
So without going through the store command, pretty much no. I don't know how that would be doable. That would be a lot of work and would not be, it's not designed for that. Really, in order for the system to know where the data is, you have to go for that store, because that's what's going to create all the index. Eric will talk about that more, but that's what's generating all these indices that that you need to go and find your data later on. And if you don't generate this index,
can't you make a register command?
Well, let's not go into this technical discussion now. That's not the place for that. I think that's very good. So, we have the backgrounds. We have the files that are in YODA format. So we have a number of supported formats that the idea is that also it's possible with some files, not with others, depending on the format, that R2D2 will check that you're not lying to it when you're putting things in. So if you put the date, it's not the date that's in the file, it will tell you, you're lying here, but that's not implemented at the moment, but it would be nice to have that extra feature. But that depends really on the file format. And so, sometimes it's nice. Sometimes it's nice. But, you in an operational system, you don't want accidents like that to happen. So you want to put a layer of checking things. So we'll try to build. That's why it's difficult to support things that are, that are all over. We need a bit of structure in order to build this index and know what is where. And also the important part is there's consistency. If you're running on Clementin's laptop or on AWS or on Orion, if you fetch a file, the system will check and you're getting the same file. So it has a consistency checks across different platforms. So there is a bit of if we want to be able to to reproduce experiments, we have to ensure that consistency and ensure that we have these levels of checks. That's why it's difficult to just put anything in there. You could put all your pictures in there, but that's, yeah. But it will evolve a lot. Obviously, GMA was fully involved in this R2D2 development, and potentially it could grow a lot and become a service that becomes available for the science community, that everybody could just go and fetch and say, okay, that observation type for that date and fetch and do whatever they want with it. Obviously, somebody needs to fund that. The storage is not for free, so we'll have to see. Yeah. Okay. So next steps before we stop. So what we at the moment, everything is very flexible. You can run with many different models. What we need to add here is the support for multiple models in the same experiment. And then so that we can go toward, I say multiple coupled. I don't like this idea of weakly coupled, strongly coupled. It's all, you could imagine a very, very weakly coupled where you just have two models working side by side without being coupled, all the way to a fully coupled everything. And so we need to add the support for that. It's probably not a lot of work that needs to be done. Tutorials, they are, we have some documentation, but it's not completely all there yet. So we're going to develop some tutorials, and we're going to really use that environment for teaching this environment and for teaching DA. I think that's a very nice tool. What we want to work on, I touched on that a little bit, is management of experiments. So that means several things. That means being able, storing all the information so you can actually reproduce an experiment and be confident that it's really reproducing the experiment you originally ran. That's why we need to track the data. Eric will talk about that tomorrow. Track which version of the code, the tags of the code, the actual commit that were used for that experiment, and etc. So you can later on come and say, copy that experiment, rerun it, and be confident it's really reproducing your experiment.
From what you were showing, and then somebody edited this, what's missing from that process now?
So it's like, for example, the experiment we just ran here on Martin's laptop. If I came back tomorrow, we didn't store the commits, like the version of the code, which branch of the code. We were running on develop for the code, but we didn't store that. So we need to be able to store that and fetch it, get it back later on.
Along the lines of this storage stuff for reproducibility, isn't it, when you're talking about models like MPass, GEOS, and heaven knows what, the complexity of that is much larger, right? Because GEOS, for example, has a zillion of boundary condition emission files, and that's even worse. So how do you plan to sort of keep track of that?
Yeah, there will be some work to do there in order to, but so I think Dom will tell you SpecStack is a nice step towards that, because you have all your base library, you know what they are, you have the hash of a SpecStack, so you know exactly all the underlying libraries, and then you build, but yes, there is a lot of information to record, and if all the data is in R2D2, then in principle you know where you got it from, and you can fetch it again and. But I agree, it's complicated.
Yes, if you have the hashtag, you get the source code guarantee, but you don't get the supporting fields that actually allow you to run it. So it could be that somebody changed that, and so.
Yeah, so the backgrounds are in R2D2. We plan to put a lot of the what's called fixed files, that also in R2D2, so they get fetched from there. So then you can have version there, and you can tell the database on that version. But yeah, it's going to come gradually. We're not going to do that in one day. Yes, and as I said earlier, also the GUI that's a little bit nicer than VI to go and edit these things. It's actually Tom has a lot of ideas how to do that, so we'll let him do it. And more and improved diagnostics, as the big thing that's really missing that so it's that we run these two experiments, but we don't have a tool to really do a plot of a difference, and that's something we really need to be able to do. And we discussed support for Silk already, so that's also something we want to work on. To the last slide. Okay, so last slide. Well, I think we've covered most of the points here, and Tom kind of already mentioned them in the introduction, but just to reiterate, the idea is, we would start, and we've started a little bit with, CSU in particular, to develop some this JEDI EDU for training students, where we would start from a Lawrence model, QG, shallow water, go all the way, and the idea is that they would use the same environment. So when they come and they get a job at GMAO, lucky ones, from day one, they know how to run that system. But it's yes, and we're also putting in place. So we have these high resolution runs for Skylab. We'll have what we call a medium resolution and a small that you just saw on the laptop. So that's this kind of idea of hierarchical testing. You can do a quick test on your, in the C12 or something to see, okay, and then you move to a whatever C96, and then you can move to C384 or whatever resolution you want. That's all in the same system. You just change a few lines. One thing a few of the partners of the JCSD said they're interested in is this. So it's this O2R, so it's proxy apps. So we would like, with all of you, to build applications that we can put in that environment that mimic what you're using in your different labs, or so that we can actually that's the number of, and we can actually test something that's relevant for you. Students can learn something that's relevant for you, etc. So we would like to build these proxy apps. The goal there is not going to, Guillaume was talking about this last mile. We don't necessarily want to do the last mile in these proxy apps of all the downstream, product generation that an operational system might have and things like that. But hopefully something that's close enough that is relevant for you.
Like a reasonable set of observation YAMLs or something like that. That's kind of representative of our configuration.
Yep.
That kind of thing.
Yes, and if you running a 4D envar, we'll put a 4D envar in there, and this kind of that it's kind of ballpark what you're running, so that it's close enough. Yeah. Yes, when we apply to GMAO, we'll be able to show you the experiments we've run, and you can look at them. And finally, the thing that so we are doing in the core team, and we're hoping the in-kinds are going to start doing soon, is this, is the what we call R2O, at least the first step of it, that people have a branch, they would run an experiment with that branch, they can look at the result. If it's good, they do a PR, it gets merged, it gets in the next quarterly release of the of JEDI Skylab, and then it's available for all the partners. So people in the team are already starting to do that, and we are really hoping that more and more people in all the in-kinds can also start using that soon. And anything more to conclude?
That's it. So basically, just to the take-home message, we're planning on releasing that service sometime in the summer. There's still some work to do to document and package it. Just the take-home message is really focusing on ease of use, and at the same time making it flexible to actually allow for sandbox experiments, really for scientific experiments to be blossoming.
Well, the question to you then is, when is the next academy? Because it almost sounds like you could have another academy.
So we're actually planning on using this environment for the next academy. So there's a little bit of a chicken and egg thing. We're trying to actually make sure we have the timing right so that we do this. So I think we'll get there soon in scheduling that.
And we didn't kill the laptop, but Clementine will get a new one soon.
It's, well, yeah, there's a bit of time left for the posters, for those additional posters today. So please have a look, and we'll adjourn around 5 o'clock. It's been a really great day. I enjoyed it. I learned a lot. Thanks everyone for all the sessions, and enjoy the posters.